Hey there, and welcome back. Today we're doing a deep dive into Microsoft Fabric billing.
Yep, specifically that capacity model concept.
Exactly. We know you, our listener, have been looking into this, shared some great resources, so our goal here is really to just cut through the noise.
Get you a clear picture of what this capacity model actually is.
Right, how it's different maybe from other billing you've seen, and just help you, navigate fabric costs without any nasty surprises.
And we'll use a couple of analogies that came up in the source material, too. They should help make it click.
Okay, sounds good. So let's kick things off. What exactly is this capacity model in Fabric?
Okay, so the core idea, and it's really fundamental to Fabric billing, is that you're essentially pre-purchasing a set amount of compute power.
Pre-purchasing, like reserving it.
Exactly. It's yours, available all the time. It's not about paying, per report view or per data refresh job.
Okay.
Instead, you've got this consistent level of processing horsepower and memory ready to go, whether your systems are running full tilt or, things are quiet.
Okay, so let's unpack that a little. If, say, my team runs fewer reports 1 month, or maybe our data flows don't refresh quite as often, does my bill automatically go down?
No, and that's a really key difference with this model. Just using less of the power you've already paid for, well, it doesn't automatically cut your bill. The cost is tied directly to the specific capacity level, the tier you picked. If you want to see savings, you'd need to actually go in and scale down your purchased capacity level.
Right, so it's less like paying for electricity where using less means paying less and more like something else. Why did Microsoft go this route for Fabric? What's the thinking behind it?
Well, there were a few reasons highlighted in the materials you showed. A really big one is enabling those unlicensed users, the free users, to view content in premium workspaces.
Okay. So because the cost is on the overall capacity, not per user.
Precisely. It means organizations can share, say, Power BI reports with lots of people who just need to view them without needing a paid license for every single one of those viewers.
That's actually a pretty significant benefit, especially for wider distribution. So for teams with lots of viewers, but maybe fewer creators, this could be more cost effective.
It definitely can be. And, if your capacity is generally being used pretty heavily, consistently, then yeah, the capacity model can be very predictable and potentially quite cost effective.
Predictable because the cost is fixed each month for that tier.
Exactly. You know what that compute part of your bill will be. But, and this is the caveat, the cost effectiveness really hinges on you actually utilizing a good chunk of the capacity you're paying for. High utilization is kind of key.
Okay, makes sense. So we're buying this fixed chunk of always-on compute. Now, the materials you provided mention SKUs. What are SKUs in this context? How do they fit in?
SKUs are basically the different sizes. Think of them as the different tiers or packages of capacity that Microsoft offers.
Like small, medium, large.
Sort of, yeah.
Yeah.
And because you're paying for this defined amount of compute, picking the right SKU, the right size for your actual needs is, well, it's absolutely critical for managing your costs.
Right. You don't want to pay for a huge engine if you only need a small one, but you also don't want to be underpowered.
Exactly that. It's finding that sweet spot.
So how do you figure out the right size then? Sounds tricky.
Yeah, it's a balancing act. The resources you looked at give some good advice here. Often, a good starting point is to use a pay-as-you-go, a scale.
For flexibility.
Right. And then this is really important. Use the Fabric Capacity Metrics app. That tool is key.
Okay, the Metrics app, what does that show us?
It lets you see your actual usage, how much compute your reports, your data flows, your notebooks, all that stuff are really consuming over time.
So we use the app to monitor usage. What are we looking for? What tells us if our SKU size is right?
The general guidance from your sources is to aim for somewhere around 80 to 85% utilization.
80 to 85%. That sounds quite high.
It might feel high, but it's generally seen as a good target. It means you're getting value, right? Your capacity is working hard, but it also leaves you a bit of headroom.
Headroom to avoid things slowing down or getting throttled.
Exactly. We'll talk more about throttling later, but yeah, that's the idea. Keep it busy, but not completely maxed out all the time. And the key is, monitoring this isn't a one-off thing. You use the Metrics app to keep checking in and refining that SICKI choice.
Makes sense. The resources also mentioned a table with memory limits and other constraints for different SKUs. We don't have the table itself, but what's the main point there?
Right. The table basically shows that as you go up the SKU ladder, you don't just get more raw compute, like speed. You also get higher limits on things like memory, how many direct query connections you can run at once, how much parallelism your refreshes get.
Ah, so it's not just speed, it's also about handling bigger data, more simultaneous users, things like that.
Exactly. Those other constraints can really impact how well your fabric stuff performs and scales, so it's part of picking the right SKU size, too.
Got it. Any other tools mentioned that help with picking a SKU?
Yes, the Fabric SKU calculator was mentioned. That sounds like a tool where you can maybe plug in your expected workload or your metrics data and get some recommendations.
Okay, another tool to check out.
And then once you do find that SKU that fits well consistently, the materials mentioned reserving it for a year. That usually comes with a discount, which is another cost optimization angle we'll probably cover more later.
Okay, so SKUs are like different plan sizes with different power and limits. Got it. Now, to make this even clearer, the material you shared brings up that phone contract analogy. How does that help us understand this capacity model?
Yeah, the phone contract analogy is pretty good, actually.
Yeah.
Think about your mobile plan, right?
Yeah.
You usually sign up for a set amount of minutes, texts, maybe gigabytes of data each month.
Yeah, for a fixed price.
Exactly. And whether you use every single minute and byte or you barely touch your phone that month,
Yeah.
you still pay that same fixed price, don't you?
True. Okay, I see the parallel. We pay a fixed price for the fabric capacity SKU, just like the phone plan bundle.
Precisely. And, just like your phone provider might throttle your data speed or even cut you off if you blow past your allowance.
Yeah, that dreaded slowdown.
Right. Fabric also has mechanisms to manage things if you try to overuse the capacity you've bought. It helps prevent runaway usage, similar to how the phone company manages their network. There are controls.
That's a really helpful comparison. So going over my fabric capacity is a bit like hitting my data cap. Things might slow down or stop until, I guess, the next billing cycle or until things calm down.
That's the general idea, yeah.
Yeah.
But as the source material itself points out, it's not a perfect analogy. There are nuances we'll get into later. But just for wrapping your head around that basic idea, fixed price, defined resource, usage controls, it's pretty useful.
Okay, core idea. Fixed cost for a set amount of resources, regardless of how much we use within those limits.
Got it. So let's talk actual cost structure then.
Yeah.
How does the billing work based on this?
Well, like we said, the main driver is the SKU you choose. That SKU has a fixed monthly or sometimes hourly, if you're pay-as-you-go, rate associated with it. And that rate is what you pay, largely independent of your minute-to-minute usage.
And for specific prices? For the exact numbers, the resources point you straight to the Azure pricing calculator. You'd search for Fabric, pick your Azure region, and it'll show you the costs for the different SKUs.
Right. Always go to the official calculator for current pricing. The material also mentioned cost scaling linearly in the same region. What does that mean practically?
Linear scaling just means it's predictable. If you double your compute power by going, say, from an F32 SKU to an S64 SKU in the same region, your costs will basically double too.
Okay, so 2 times the power, 2 times the cost. Simple enough.
Pretty much, yeah. Within that same region, it's a direct relationship.
And again, the reminder about potential savings with those one-year reservations if you commit.
Okay.
One last cost point mentioned. Free users need an F64 or higher capacity to view Power BI reports, same as the old P1 SQ. Why flag that specifically?
Yeah, that's important if you have people in your organization who need to see reports published to a premium workspace, but they don't have their own Power BI Pro license.
The free viewers.
Exactly. To enable that viewing capability for them, you need to be running on at least an F64 capacity. So, if that's a requirement for you, that F64 becomes your minimum starting point for SKU selection and, therefore, your minimum cost consideration.
Right. So if you need free viewers, F64 is the floor. Good to know. Now, you hinted earlier, and the resources mentioned, that while the basic model seems straightforward, things can get more complex.
Yeah, the basics are fairly simple. Buy capacity, pay fixed rate.
Huh.
But the materials do mention some scenarios that add layers, and they plan to cover these more later.
Like what kind of things?
Things like mixing pay-as-you-go and reserved instances together in your billing. Or the implications of pausing your capacity, maybe overnight, and then restarting it. Or scaling up to a bigger SKU for month-end processing and then scaling back down.
Ah, okay. So managing the capacity dynamically or using different payment methods side by side, that adds wrinkles.
Exactly. How you manage and pay for that core capacity introduces these other considerations. But for now, just understanding that core model pay for always on compute is the main thing.
Got it. Simple base, potential complexity in management. Okay, let's shift gears slightly. The info you shared talks about an evolution from vCores to something called capacity units, or CUs. What's that about?
Right. So CUs, capacity units, This was basically a change in the unit of measurement for fabric capacity. Think of it like switching from measuring distance in miles to kilometers.
Okay, just a different unit. Why change?
The main idea was to allow for more granularity. V-cores were maybe a bit chunky as a unit. CUs are smaller units, which lets Microsoft offer a wider range of capacity sizes, especially at the lower end.
So smaller steps between CUs, potentially lower starting prices.
Exactly. Makes Fabric potentially accessible for smaller workloads or budgets. And the important thing to stress for anyone who's using Power BI Premium before this change is that the actual throughput, the actual power of their existing capacity didn't change.
Ah, so my P1 capacity didn't suddenly get weaker or stronger?
Nope. It just started being reported in CUs instead of V-cores from, I think it's October 2023 onwards. Same engine power, just a different number on the dashboard, if you like.
Is there a conversion rate we should know?
Yep, the key conversion is 1 Power BI V-core is equivalent to 8 Fabric CUs. They deliver the same amount of work per second.
Okay, 1 V-core equals 8 CUs.
So that P1 capacity you mentioned, which used to be 8 V-cores, now it's represented as 64 CUs. 8 times 8.
Got it. The source material even had a little calculation example for a 30-second window, right?
Yeah, it illustrated the point. With the old 8 V-cores on a P1 over 30 seconds, that's 8 times 30, which is 240 V-core seconds of work potential.
Okay.
Now, with the equivalent 64 CUs over the same 30 seconds, that's 64 times 30, which equals 1920 CU seconds.
Different numbers, but the same amount of actual compute work done in that time.
Precisely. It's just a more fine-grained way to measure and sell the capacity.
Right? Allows for those smaller F-SKUs at the bottom end. Okay, that makes sense. Now let's dive into these concepts of bursting and smoothing. These sound really important for how the capacity model actually handles real-world usage spikes, especially with the Gen 2 architecture. What are they?
Yeah, bursting and smoothing are critical. They were big features of the Gen 2 premium platform that Fabric is built on. Basically, bursting lets your workloads temporarily use more capacity than your SKU technically provides.
Go over the limit.
For a short time, yes. And smoothing is how the system accounts for that temporary overage. It spreads the cost of that burst over a future period.
Okay, so if we get a sudden rush of users hitting a report, bursting lets us handle it.
Yes, without immediately failing or throttling. The system then uses smoothing to kind of average out that spike. For interactive stuff, like a user clicking around in a report, that usage spike is typically smoothed over the next 5 minutes.
5 minutes. And for background tasks, like data refreshes.
For background things like a semantic model refresh or running a notebook, the smoothing window is much longer. It's spread over the next 24 hours.
Wow, 24 hours. So what's the big advantage of having this burst and smooth capability? Why not just have a hard ceiling?
The main benefit is efficiency, really. It means you don't necessarily have to buy capacity size for your absolute peak possible moment, which might only happen for a few minutes a day.
Ah, like that early morning refresh storm when everything kicks off at once.
Exactly. Bursting can let those complete, even if they momentarily push usage way above your normal SKU limit. Then smoothing spreads that temporary high usage over the next day, when things are maybe quieter. It avoids you having to pay $247 for capacity you only need for 20 minutes.
That makes a lot of sense from a cost perspective. Avoid paying for the absolute peak. The resources mentioned, each SKU gives a certain amount of CU seconds per second pooled into 30-second windows. Can you explain that CU budget idea?
Sure. Yeah, think of each CU having a rate of earning CUs. An F2 earns 2 CUs every second, and F64 earns 64 CUs every second, and so on.
Okay, a constant flow of CUs based on the SPU size.
Right. And the system kind of groups these into 30-second buckets, so that F64, earning 64 CUs per second, gets a budget of 64 times 30, which is 1920 CU seconds to spend in each 30-second window.
A 1920 CU second budget every half minute for an F64. Okay. And how does this budget work with bursting and smoothing? What are the rules?
Okay, few key rules. 1, you get that budget as soon as the capacity is running. 2, if you don't use all the CUs in a 30-second window, they're gone. No rollover for unused budget within that window.
Use it or lose it every 30 seconds.
Kind of, yeah. But, and this is the bursting part, you can borrow from future 30-second windows.
Oh, that's the key.
Yes. Bursting is essentially spending more than your current 1920, the F64 case, by dipping into the budget that's coming in the next few windows. Smoothing is then the mechanism that tracks this borrowing and ensures it's accounted for over time, 5 minutes for interactive, 24 hours for background.
So you're constantly earning CU budget, spending it, maybe overspending, bursting, by borrowing from the near future, and then the system tracks that borrowing smoothing.
That's a good way to put it. And because background smoothing happens over 24 hours, it's helpful to think of your budget, especially regarding background tasks, as this sort of continuously rolling 24-hour window of available CUs you can potentially borrow against.
Okay, this rolling budget idea helps. Let's make it super concrete.
Yeah.
The resources had an F64 example with a big background refresh. Can you walk through that?
Sure, so F64 budget is 1920 CU seconds every 30 seconds. Let's say you have a background refresh job that needs a whopping 2,880,000 CU seconds total to finish.
Way more than the 1920 available right now.
Way more, but Fabric lets it run. Through bursting, it starts consuming CUs. And through smoothing, that total cost of 2.88 million CUs is divided evenly across the next 24 hours worth of 30-second windows.
How many windows is that?
24 hours is 2,880 30-second windows. So 2,880,000 CUs divided by 2,880 windows means that refresh job will consume 1,000 CU seconds in each 30-second window for the next 24 hours.
Okay, so it borrows heavily up front, but the repayment is spread out as 1,000 CU seconds every 30 seconds for a day. What about the rest of the budget in those windows?
Good question. Our F64 window budget was 1920 CU seconds. If 1,000 are being used by the smooth background job, that leaves 1920 minus 1,000, which is 920 CU seconds remaining in each of those 30-second windows.
And that 920 can be used for other things, like interactive reports.
Exactly. Interactive queries, maybe even another smaller background task, can use that remaining 920 CU seconds. But remember, any part of that 920 that isn't used in that specific 30-second window is still lost. It doesn't build up.
Okay, that example really clarifies how a big job gets spread out. But the resources warned about maybe overdoing it, right? Running too many big jobs at once. What happens then?
Right. If you kick off too many large operations, especially background ones, you can essentially mortgage too much of your future capacity. You might borrow so heavily that your upcoming 30-second windows have very little or even zero budget left after accounting for the smooth load.
And
then you hit throttling. The system will basically say, nope, capacity is overloaded due to past borrowing, and it won't let new operations start until some of that smooth load clears, freeing up future budget.
So bursting gives flexibility, but you can still paint yourself into a corner if you consistently try to borrow too much.
Precisely. You still need to manage the overall workload relative to your capacity size. The smoothing just gives you tolerance for temporary peaks, not sustained overload.
Okay. Now, something that caused a bit of confusion in the material was this mention of 10 minutes of overage protection versus the 5-minute smoothing for interactive jobs. Can you clear that up? How do they relate?
Yeah, that's a good point to clarify. They're different things. The overage protection is a hard limit. You get a total pool of typically 10 minutes per day per job type, interactive or background, where jobs are allowed to actually execute using more CUs than your capacity provides. It's a safety net for brief, genuine overloads.
Okay, a 10-minute daily quota for actual bursting execution.
Right. Now, the 5-minute smoothing for interactive jobs is more of a delay tactic. If an interactive job starts and the system sees capacity is really high, it might hold that job back for up to 5 minutes, hoping the load drops.
So it waits to see if things quieten down before letting the job run hard.
Exactly. It's trying to avoid needing to dip into that 10-minute overage quota if possible. Importantly, that 5-minute waiting period, the smoothing delay, does not count towards your 10 minutes of overage.
Ah, so smoothing waits, overage is for actual overcapacity execution.
Yes. Overage minutes only get consumed if, after any smoothing delay, the job still needs to run using more CUs than available. And once your 10 minutes for interactive jobs for the day are used up, any further interactive requests that exceed capacity will be throttled immediately.
That's a crucial distinction. Smoothing is preventative waiting. Overage is the actual burst allowance.
Got it. Now let's talk carry forward capacity usage reduction. Sounds technical? What's that about? Using idle capacity.
Yeah, carry forward is basically the term for the debt you accumulate when you use bursting. It's the log of how many CU minutes you've consumed beyond your limit.
The debt from using the overage allowance.
Exactly. Now, the reduction part happens automatically. Whenever your fabric capacity isn't fully busy when it's idle or partially idle, the system uses that unused compute power to pay down your carry forward debt.
So quiet periods automatically help clear the slate from earlier bursts.
Precisely. The more idle time you have, the faster that carry forward balance gets reduced back towards zero over that rolling 24-hour window. But if the system is constantly busy, even with smoothed background jobs, there's less idle capacity to pay down the debt.
Right. High utilization, even from smooth background tasks, means less idle capacity, so any carry-forward debt you have will take longer to clear naturally.
Okay, that makes sense. Idle time equals faster debt repayment. Now, back to background jobs for a sec. Why do they have both that 10-minute overage limit and the 24-hour smoothing carry forward thing? It seems redundant.
It does seem a bit confusing, but they serve different purposes. The 10-minute overage limit is that real-time hard cap we talked about. It prevents any single background job or interactive job from overwhelming the system by bursting for too long right now. It's an immediate throttle point.
The emergency brake?
Kind of, yeah. The 24-hour smoothing and carry forward, however, is the accounting system for the debt incurred during those allowed bursts within the 10-minute window. It's how the system manages the repayment of borrowed CUs over the longer term using idle capacity.
So 10 mins is the max burst duration now. 24 hours is the time frame for accounting for and repaying a cost of that burst later?
Exactly. No job bursts beyond 10 minutes. The carry forward debt created within that allowed burst is what gets managed over the next 24 hours.
Okay, that clarifies the two timescales. Now, the credit card analogy came up again in the resources as a really good way to tie this all together. Can we revisit that in a bit more detail?
Definitely. It's quite effective. So think of your fabric capacity SKU size as your credit card's daily or monthly spending limit.
My CU budget.
Right. Bursting using that 10-minute overage is like maybe having overdraft protection or briefly exceeding your credit limit.
Yeah.
It's allowed, but only up to a certain point.
Okay.
The carry forward, the CU minute debt you accumulate during bursting, that's your credit card bill. It's the record of your overspending.
Makes sense.
Idle capacity in Fabric is your repayment power. Just like you use your income to pay your credit card bill, Fabric uses its idle compute cycles to automatically pay down that carry forward bill.
Automatic payments when the system isn't busy.
Yep. The 24-hour rolling window acts like the billing cycle. It's the time frame over which this debt is tracked and ideally repaid.
And throttling.
Throttling is your card being declined. If you've maxed out your limit, use your overage, and you haven't made enough repayments, had enough idle time to clear carry forward, the system stops new transactions, it pauses new jobs.
That analogy really holds up well. Limit, overspending, bill, repayment, declined. Okay, let's apply this to one last scenario. That long-running background job, say 1 hour, needing more capacity than the SKU provides. Walk us through it minute by minute using these concepts.
Okay, 1 hour job needs more CUs than the baseline.
Yep.
Minute 0 to 10. Bursting happens. The job likely runs faster than the baseline capacity would normally allow, consuming CUs above the limit. This creates carry forward debt.
Okay, fast start, accumulating debt.
Minute 10, approximately. The 10-minute overage quota for background jobs for the day is likely exhausted by this single job. Bursting stops.
Hit the burst limit. Now what for the next 50 minutes?
Now it depends. If there happens to be spare capacity within the normal SKU limits, i.e. other jobs aren't using all the CUs, the job will continue to run, but likely at a slower pace, using only those available baseline CUs. It's not bursting anymore.
Okay, continues slowly if there's room.
But if the capacity is already fully utilized by other processes, including maybe the smoothed load from this job's own burst, then the job will be throttled. It gets paused.
Paused entirely.
Potentially, yes. It will sit paused until either some baseline capacity frees up, or perhaps until the 24-hour burst window resets, allowing it to potentially burst again if it's restarted or retried.
Yeah.
So after the initial 10-minute boost, it's entirely reliant on standard available capacity.
So that initial burst helps it get going, but it doesn't guarantee it finishes quickly if it's a long job and the system is busy. It might run slow or just stop after 10 minutes.
That's a critical takeaway, yes. Bursting helps with the start, but sustained performance for long jobs depends on having enough baseline capacity or managing concurrency carefully.
Wow, okay. This has been incredibly useful. We've really unpacked the capacity model, SKUs, CUs, and especially bursting and smoothing. Those analogies were genuinely helpful too.
Yeah, the main things to remember are capacity model means paying for always-on compute, picking the right SKU is vital, and bursting and smoothing are your tools for handling peaks efficiently, but they need understanding to manage well.
And like you said, while the core idea is one thing, managing it with reservations, pausing, scaling, that's where the next level of complexity comes in, which we'll tackle in future deep dives.
Exactly. But getting this foundation right is definitely step one for managing fabric costs and performance effectively.
So a final thought for you, our listener, to chew on. Now that you've got a firmer grip on this capacity model, the SKUs, the bursting, how might you look at your current fabric setup or your plans differently? Could you optimize your SIGI? Adjust how you schedule jobs, maybe? Definitely something to think about.
Absolutely. Always worth reviewing based on new understanding.
Well, thank you for joining us for this deep dive. As always, if there are other fabric topics, billing or otherwise, you'd like us to get into, do let us know.
Yes, thanks for tuning in. Hopefully this clarified things and gave you some practical insights into fabric billing.
Until next time, keep exploring.